Find the inverse matrix of -3, -3, -4, -3. So the inverse matrix is found by taking 1 over, and let's just call this A, 1 over the determinant of A times the matrix found by taking A and B, or A and D, and swapping them. So your bottom right and your top left swap. Your top right take the opposite of, and your bottom left take the opposite of that. So what we need to do first is we need to find the determinant. Then once we find the determinant, that will let us know if we could even take the inverse. So let's do that. The determinant is found by multiplying u times u, the top left and the bottom right, so -3 times -3, and then subtracting u times u, so -3 times -4. Okay, so 9 minus 12 is -3. Now, the determinant is -3, which means, yes, we could take the inverse of this matrix. The only time we couldn't take the inverse of the matrix is if the determinant is 0, because you would get 1 over 0, which is undefined. That's impossible. Now what I need to do is I need to take 1 over -3 and multiply it to this matrix rearranged. So let me get a different color and write out 1 over -3, so -1/3, times swap the A and the D, which does absolutely nothing. Make -3 positive because it's the opposite, so positive. You become +4 because you take the opposite of the bottom left number, and then you just do scalar multiplication, which means you take that -1/3 and multiply it to every element in here as if it was distributed property. So -1/3 times -3 is +1. -1/3 times -3 is -1. -1/3 times +4 is -4/3. And -1/3 times -3 again is +1. And that's your inverse matrix.